Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this one, we're going to yet learn another way to optimize our codes, but this time we are going to focus on our data types. Basically, I'm going to show you in a few different cases and examples that how having chosen an appropriate data size could make your code faster and take up, of course, less space, and also at the same time allow you to do more meaningful analytics. All right, so this video is going to be basically I present to you a situation that your code is running, an example is running, sort of slow. By changing the data type, we make it faster. All right, let's get started. Okay, so the two main modules that we always use, NumPy and Pandas, we are going to import them, and also I'm going to use PCA as an example model that, if we have a big data set, it's gonna run slow. If we have big data set and we haven't set our data types appropriately, right? So let's import these modules. And then next, I am creating a test data frame, basically using NumPy random. I'm creating rand int, which is basically a function that creates random integers. From 1 to 5,000, these random integers going to be like between these range. And I am creating 50 million rows. So this is, the idea of a perhaps big data, and 50 million rows, and like I'm creating 3 columns, right? Column 1, random column 1, random column 2, and random column 3, right? So that's my data, and it takes a bit to create this data. As this, it's a huge data. It wasn't too long, but it takes a bit. And this is my data test DF, right? You can see that it has 3 columns, and these are my numbers, and I've got 50 million rows, right? So now next I want to run PCA. If you don't know PCA, feel free to watch my video that I talk about PCA. But here, just think of it as an analytics. If you don't know what it is, it's just something you need to do your data sometimes, right? And because the data is big, it's gonna take a while, right? I think this one is gonna take around 10 seconds to run. But don't worry, I'll put music when you are having to wait to see this, right? So let's click and see how long it's going to run, and we take it from there. Alright, it took 7 seconds to run this, right? So 7 seconds for 15 million is a lot. I mean, as you go higher in your data size, 100 million, 200 million, a billion, this time will exponentially increase, right? So we want to see if there is something we can do about this, right? And that thing might just be changing your data type, right? So let's just look at the information for this test DF. It's telling us the data type for random column 1 and 2 and 3 are int32. And this is how much space this data frame is occupying in our data, right? In our memory. So now we're starting to become curious about this integer 32. Let's look at what is the range that this int 32 can accommodate us with, right? We can use this npi info function to tell us the minimum and the maximum of any data type that is known to NumPy, right? So I click on this and it tells me that if I'm having integer 32, I can have numbers, let me just see how many zeros this would be, have around 2 billion, right? 2 billion, from negative 2 billion to positive 2 billion. Right, so this is 3 zeros, another 3 zeros, another 3 zeros, right? Around 2 billion. And this is way too large of a range for my numbers. My numbers were from 1 to 5,000, right? So now let's check int 16. Like, it's just too much for me. I'm not going to need all of those. When we go to int 16, now we are more reasonable, 32,000, right? From 2 billion to 32,000, right? Might be still like too much. Let's check int 8. Once we check int 8, integer 8, we can see like this is now too small for us for this purpose, which is 1,000 to 5,000, right? So we figure out this int 16 is a better data type for us. So we can simply change with using the pandas as type to int 16. And this just does the trick for us. And now we check the info. Now we can see everything is int 16, but also pay attention, our memory, the amount of memory we're using is half of what we were using, right? It was 532 megabyte, now it's 286, which is an improvement by itself. But now this is what we want to be looking at. Did changing the data types going to make my model run faster, right? Let's just click and see and compare, right? So once we click this, we see that instead of 7 seconds that it used to, now it takes 4 seconds, right? Almost half. It's not quite half, but there is a lot of improvement that we can see that this change of type accompanied us with, right? So this is something to work with. Instead of having to wait 7 seconds, now we can wait 4 seconds. And when the size of the data gets larger and larger, and this becomes more and more meaningful, right? So that's one thing. Making sure that the data that you have, you're not just splurging the memory, right? Making sure that you're setting the memory that you're going to use. So that's with integer. Let's experience the same thing, this time with just floating points, right? So with the float data type, right? So with the float data type, we have to also check it. But before we can do that, let's create some float data types, right? This time, instead of using rand int, we're just using random, which basically gives us numbers between 0 and 1, right? So all of these numbers that were generated just between 0 and 1, these are just floating points. So let's see what is the typical floating point that NumPy generates. When we look at this, it's float 64. And it is using 1.1 gigabyte of data. And when we run such, large data, you can make sure, you can be pretty sure that this is gonna last long. This time it lasts 6.32 seconds. So now let's check if we can find another data type that does not require as much space, right? So we check the floating point for 64. And it's between, it's such a big number, right? It's like very big number. But let's check for float 16, which happens to be the smallest possible floating point for NumPy and pandas, right? So this is the smallest possible, and our data fits comfortably with this 2 range, right? So why not just use float 16, right? So we go ahead and use float 16 instead of float 64. The default that it put for us, and we can see that our data is intact, meaning that we keep the same data, but we're just using less memory, much less memory. This time we are not using gigabyte, we're using 286 megabyte, right? So if you remember, we're using 1 gigabyte. Now this is the real test. Now we want to check if this did anything for our analysis time or complexity of this procedure for this big data. So once we click, we see from 6 seconds we are getting to 4 seconds. Again, not half. It doesn't half it. It's not like 3 seconds, but still a lot of improvement. So these were 2 examples of doing data allocation, or allocating the data type. By allocating the data type, we're able to make our code run faster. But I'm going to show you 2 more examples that we can also be more efficient with some analytics when we set our data types more smarter, in a smarter way, right? So let's do some sort of change to the data so we can build that challenge that we'll see together. So I'm going to use the function where, numpy where, to basically categorize this random column 1. Instead of having a number, I just want to have a category, right? High or low, like H or L. If it's larger than 0.5, it's high. If it's not, low, right? So I go ahead and do this. And once this is done, we will check the info, which instead of a floating point, now we have an object. Now pay attention, object, which in this case is a string, is larger than the floating point 16, right? It was 286 megabyte, but now it's like 500 megabytes. So it's like the object is like a little bit, takes more space in your computer, right? So for instance here, if we want to do something like a group by based on this categorical attribute, which is a string here, it would take a good amount of time. Let's go ahead and check this, like how long this would take for us to do this analysis if we just keep this a string or object. It's 6 seconds. So this is a string, but it only has two possibilities, right? Using object or string for this type of sort of data is again splurging. Pandas allows us to use a data type called category that is going to just use much less space in your computer, right? So once we change this to category, not only we're going to be able to use much less space, right? So it used to be almost 600 megabyte. Look at this, it's now 238 megabyte. But at the same time, if we do the same analysis by having just changed the data, we have 5 times faster calculations, right? 5 times, almost 5 times faster. Not 5 times, 3 times faster, but like 4 seconds faster, right? So this is a significant achievement by just specifying the category when you have a category. I mean, it's not a string. A string is for a name that you will have different sort of assortment of characters for every name. But here is just you have 2 possibilities. When you have 2 possibilities, you want to make sure that you specify that as category, right? So that was one example. Let's look at another example, but this time it's going to be a combination of sort of like, you know, being optimizing for size and computational time. But this time I'm going to show you when you set the data type smartly, it allows you to also do other types of analytics that if you had not done that, you wouldn't be able to do that, right? So let's make our random column 2, instead of just high and low, have 4 different categories. Like we've got low, mid-high, and high. Like, so if it's like smaller than 0.25, it's low, so on and so forth. So we've got 4 categories this time, right? So let's go ahead and give this a try and see now how much this would take. Of course, this is going to be a category, object, and then it's going to be float 16. And it's going to be a little bit more than this. It's like 500 megabyte, right? So this is object. We haven't specified this as category. So let's go ahead and try to see if when we have mid-high, we want to like do some sort of conditional on this random column 2. We want to like grab the ones that are larger than medium high, right? So let's go ahead and do this. While this is running, you might start thinking, can I do this? Like, what does this mean, mid-high? This is an object, but your code seems to be running. It might work. I mean, Panda is smart enough to capture this. Let's look into it, right? So 7 seconds, let's keep that in mind. And also now let's do our group by, right? So this is 7 seconds. So let's see how long our group by is gonna last. And once we do that, then it will allow us to see that if our analysis were correct, right? So when we start looking at RC2, this is all jumbled up, high, low, mid-high, mid-low, right? So it seems that This mid-high is looking at the letters. Like when you use this for string, it says if M is after these other letters. So this is how it's sorting that for you, right? So certainly this is not what we are looking for. At the same time, this is also taking 10 seconds. So for us to be able to meaningfully sort of like compare categorical attributes like this one, right? This is a categorical attribute. We have to specify an order for our category, right? So for our category. So when we set our type, like, before we would just set type as category, right? But here we have to set as category, but we also have to set that this is ordered. The way you do this is that first you create an object as your data type, and you would like use this pandas API types category data type, and you specify your categories, and you also specify that they are ordered, right? So we are paying attention that we are specifying that they are ordered, right? So you specify your type, and then you pass your type. So this is an object you just created to the pandas column, and it sort of like transform the data for you, and then it will allow us to do the extra analytics that we were not able, or at least it was incorrect before. So now let's check the info, and the info shows us that it's much smaller in space. It used to be how much? It used to be 500 megabyte. Now it's 190. So we are saving a lot of space. But more importantly, it's going to be just faster. Look at this, 774 milliseconds as opposed to 7 seconds, thousands of times faster. But also, we are doing something we're not able to do correctly before, right? So now this time we're actually comparing with these correct orders, right? And we can also do the group by, and we'll see how much faster this will run. But also this time our values are correct: low, medium, high, and high, right? So this time our values are correct, but also it ran much faster. It's almost 4 seconds. Before it was 10 seconds, right? So we made a meaningful improvement. So in this video, basically, I posed a few situations that us having put the correct and appropriate data type had meaningful improvements for our memory, for the capability for us to do certain analytics, and more importantly, for computation costs. All right, so that's something you want to start paying attention to think about, am I putting the right data type? Another data type that we didn't put in this, I didn't put in this video, but something that you want to think about, specifically for being able to do more, as in do more analytics, is using the data type date time. I will probably in sometime in the future will create a video about this data type. But for now, if I haven't created that videos yet, please feel free to check it out. It's going to improve your coding and your analytics using Python. All right, until the next video.